Okay, so question number 8 is a two-part question. Both PCl3 and PCl5 are stable compounds. Draw Lewis structures for these two compounds. And part B, nitrogen trichloride is a known compound, but all attempts to synthesize have failed. Draw Lewis structures for and a hypothetical nitrogen pentachloride and explain why this is an unlikely structure. Okay, so first let's do part A, starting with phosphorus trichloride. So first let's calculate the total number of valence electrons for this compound. Phosphorus contains 5 valence electrons, and chlorine contains 7. And there are 3 chlorine atoms, so we multiply this by 3. And if we added it all up, we get a total of 26 valence electrons. So now let's show phosphorus as our central atom with the 3 single bonded chlorines attached. And I'll also show all of the lone pairs on my chlorines as well. And if we count out all the electrons in this structure, we only have 24 out of the 26. If each bond has 2 bonded electrons, so we just need to have 2 more electrons and they can go on our central phosphorus atom. Okay, so this is the structure for PCl3. So now let's try to do the structure for PCl5. It's going to have total valence electrons with phosphorus 5 plus the chlorine, which is 7 times 5 this time. So 35 plus 5, so that gives us 40 valence electrons. So phosphorus will be our central atom. And then I'm just going to have all of the single bonded chlorines. And show all of their lone pairs. So phosphorus is one of the exceptions to the octet rule, in which it's able to form more than 4 bonds. And if we count out all the valence electrons I've drawn so far, we should have 40 in our structure. Yep, so 8 times 5. So that is part A of this question. So now for part B, we need to draw Lewis structures for and a hypothetical NCl5. So first let's show the Lewis structure of the nitrogen trichloride. And let's calculate its total valence electrons. Nitrogen has 5, chlorine has 7 times 3, so 26 electrons in total. And similarly with our PCl3, I'll draw in all of the lone pairs on the chlorine, and our nitrogen should have a lone pair as well to get 26 electrons. So now let's try to draw that hypothetical nitrogen pentachloride. And we'll calculate its total valence electrons first. This also gives us 40. And now let's attempt to draw this hypothetical structure that will probably look like the PCl5 with all the chlorines all around it like this. Kind of going into my equation there. You kind of get the gist. So you get a structure that kind of looks like this. So this is incorrect. And I'll try to fit an explanation why up here. So if we write out the electron configuration of nitrogen, it is 1s2, 2s2, 2p3. So to form nitrogen pentachloride, we need 5 unpaired electrons, and they are required. Nitrogen only has 3 that are able to bond, I should say. Since the electrons in the s orbitals won't participate in the bonding. So the reason why phosphorus is able to form the 5 bonds is because it has another d orbital, and it's able to have multiple bonds. So this nitrogen has no expanded d orbital. There is no expanded d orbital. Okay, so let's see what the junior tutor said. They have the Lewis structures for PCl3, PCl5. Oh. Looks like they didn't tackle the second part of the question. Okay, so I said for part B, NCl5 is an unlikely structure, since to form NCl5, 5 unpaired electrons are required, and nitrogen only has 3. And then I just tried to draw its electron configuration. Nitrogen has no expanded d orbital, unlike phosphorus. I think that was like the main part of the question that should have an answer, so I'm just going to say this solution is incorrect.